Hello and welcome, I'm Albro1, and I'm here today with a tutorial on pixel movement. We've had this feature for a while now, but there are a lot of games you'll find on BYOND that still use the old tile movement system. The reasons for this vary on a case-by-case basis, but hopefully this tutorial can help out those that want to know more about pixel movement, and teach those that don't know everything about it everything they need to know. So let's dive right in. What is pixel movement? Pixel movement is just as the name implies, objects moving pixel by pixel. I've found that I'm often met with confusion when bringing up pixel movement to some developers on BYOND, so I take a different approach and explain it like this. The current movement that you see by default in your game is tile movement. Now let's think in boxes. Each tile in your world by default is 32 pixels tall and 32 pixels wide. Your mob atom also takes up a 32 by 32 square. When your atom takes a step, you move into the next tile. So you move 32 pixels forward. Pixel movement allows you to not only change the distance that your atom steps, but also change the space that they take up. This space that your atom takes up is called a bounding box. As the name implies, this box defines the boundaries of your atom. Strip away all of the pretty visuals, and this bounding box is all the code sees when it wants to know the size of your atom and determine collision with other objects. Pixel movement introduces several variables for customizing this box. Bound X is the left side of the atom's bounding box. The default value of this variable is 0. Increasing this moves the left side of the box to the right, while decreasing it moves the left side of the box to the left. This essentially moves the entire box. It does not change the box's size. Bound Y is the bottom of the atom's bounding box. The default value of this variable is also 0. Increasing this moves the bottom of the box upward, while decreasing it moves the bottom of the box downward. This also moves the entire box, rather than changing the size of the box. Bound width is the width of the box. The default value of this variable is 32. More specifically, it is the width of the default icon. The width of the default icon changes based on world icon size. Finally, bound height is the height of the box. The default value of this variable, like bound width, is 32, and it is also related to world icon size. So, let's say your default atom's icon is a 16 by 16 square centered inside of a 32 by 32 icon, like this. To adjust the bounding box so that it fits the icon, rather than being much bigger than it, you would set the bound X and bound Y to 8, and the bound width and bound height to 16. Here's a small diagram taken from BYOND's help reference that labels all of the different variables and how they interact with the atom. Since bounding boxes are used to determine collision, this means that your atom will collide against objects as close as they can be, rather than there being random space between your atom and the wall that you cannot fill. Immediately, you may see the possibilities that this creates. You can, for example, have smaller hallways to go down and design your maps in more organic ways rather than being trapped in a tile-based world with tile-based movement. Now that we have defined our bounding boxes, let's move on to actual movement. Pixel movement introduced another simple variable for us for this: step size. The default value of this variable is 32, or whatever world icon size is, if you changed it. Because the default value is 32, older games made before pixel movement was added still function the same. But modify this value and you'll see a whole new world of possibilities with your movement. Let's set it to 8 and run this test project to see what happens. As you can see, rather than moving an entire tile with one movement command, I only move precisely 8 pixels forward. When we put this into action and hold down our movement key, you will see a much smoother movement experience that feels much better than the default tile movement. Alright, now that we have a basic understanding of pixel movement, let's take a little break. Play around with pixel movement yourself and see how it feels. Next week, we will get down to the nitty-gritty of pixel movement and all the other aspects of it, and what you can do with it. I've included my test project used in this video in the description below, so feel free to check that out. Thanks for watching, guys. Remember to leave a like if you are so inclined, and subscribe if you want to stay up to date on more tutorial videos. Also remember that I have a Patreon, which you can find right here, if you are interested in seeing videos early, among other benefits. Every little bit helps me make better tutorial videos for you guys, so I really appreciate it. Thanks. See you next time.